Okay, welcome to the next video. Today is going to be on confidence intervals for p-hat and the conditions that need to be met for us to do a confidence interval. So, we talked about this last class, the difference between a confidence level and the confidence interval. The confidence level is we are 95% confident is shorthand for 95% of all possible samples of a given size from this population will result in an interval that captures the unknown parameter. Remember, we're not saying there's a 95% chance that the parameter is in the interval or not. It's either it is or it isn't. So it's a 100% chance or nothing. It's just saying that if we did this again and again, we'd get it right 95% of the time. And so when we write it in speak, we say we are blank percent confident the interval from blank to blank captures the actual value of the population parameter in context. Remember, this is where you would copy the wording from the question verbatim back at them. And this is just that same drawing again of, you know, if we did 20 different samples and confidence intervals, on average, one would miss the parameter. Remember, the dot represents the point estimator. And this is, if you notice, the point estimator is almost never truly captures the value. And so what we should do is we should be careful about reporting our statistics, and we should really focus on reporting our confidence interval. Okay. And this is more of the same. The confidence level does not tell us the chance that a particular confidence interval captures the population parameter. It tells us the chance that what percent of all such constructed confidence intervals would capture the population parameter. All right. So, the basic gist of a confidence interval is it's the statistics plus or minus a critical value and the standard deviation of the statistic. And this is one that's going to go on the board next time. So, some other things. We'll talk about margin of error. Margin of error is the critical value times the standard deviation of the statistic. So, ME equals, and then we'll start with Z star, which is what we'll omit for this unit, times the standard deviation of the statistic. So times sigma p hat for today's unit, sigma p hat, sorry. The user chooses the confidence level. You know, traditional confidence levels will be 90%, 95%, 99% will be, or 98% will be the ones we'll do. If, in the absence of instructions in this class, we'll use 95%, but if asked to find a different one, we will. And once again, if you think about this critical standard deviation of the statistic depends on the sample size. The larger the sample size, the smaller the standard deviation of the statistic. And so we're balancing these, is that the higher our level of confidence, the bigger the critical value is going to get. And we'll get a very wide confidence interval. The higher our sample size, the smaller the standard deviation we'll get, and the narrower our confidence interval will get. We'll play with this a bit later on, and certainly in class next time. So, and here we have an 80% confidence interval and a 95% confidence interval. The higher our confidence level, the wider the interval is going to be, because the critical value will increase. And I haven't told you how to find critical value yet. Don't freak out. We'll get there in a second. So, in order to calculate the critical value of, or in order to use a confidence interval, we have certain conditions that have to be met. We talked about in chapter 4 that in order to make inference about a general population, we had to have a random sample of the population. So if we're actually trying to capture a parameter, then we are trying to make inference about the entire population. So you must always check and state when creating a confidence interval that the sample was random. Most of the math we're going to do is that the sampling distribution has to be normal. And so for proportions, that means n times p has to be greater than 10 and n times 1 minus p has to be greater than 10. For means, that means we either need to sample from a distribution that is normal, or CLT has to kick in and our sample size has to be bigger than 30. And then the last thing is independence. In order to not mess with the standard deviation of the statistic, we can't sample more than 10% of the population. You will have to state these conditions and show that you checked them on an FRQ question. And so get used to the RNI, random, normal, independent. And you will be checking these on both the confidence intervals, and you will be checking them on hypothesis testing. And we'll get into this. But so the first, remember that 4-step process they've been pushing in the book and we started talking about. First step would be to state, I am going to create a blah, blah, blah confidence interval to try and find blank parameter. Then you would check your conditions, then you would show the math, and then you would state your confidence interval at the end in sentence form with context to describe what you mean. That would be the 4 steps. So, once again, I haven't described how we're going to get the critical value. The critical value we were using in class was 2 for 2 standard deviations away from the mean. But we should have all of the rest of this down. Your confidence interval is your estimate plus your margin of error. Margin of error is critical value times standard deviation. That's margin of error. Pause if you need to write down. I'm going to keep going. This is once again the definition of confidence level and confidence interval. That margin of error gets smaller as sample size goes up, and margin of error goes up as confidence level increases. Before you attempt a confidence interval, you must check the conditions. Otherwise, it's not valid. Your sample must be random. You must have a normal sampling distribution, and you must have independent. You can't sample more than 10% of the population, or else your standard deviation is messed up. All right. This is a big one that they talk about on the AP exam, is that your margin of error is your margin of error due to random variation. Right? Chance variation, random variation. It has nothing to do with problems with the experiment, or problems with the experimental design. This is if we do everything perfectly, there's still a margin of error due to the randomness of sampling. All right, so let's talk about creating a confidence interval for p-hat. All right. First things up is that the sampling distribution will be approximately normal as long as n times p, as long as np is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. The center will be p, and the standard deviation is the formula that we had for sigma p hat. Right here. So, in practice, we do not know the value of p. If we did, we would need to construct a constant in the first place. In large samples, p hat will be close to p, so we will replace p hat with p when checking the normal conditions. Basically, we'll use our statistic because we do not have the parameter value. So instead, when we check conditions, we will check n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. All right, and once again, all right, well, this didn't come in. It is a very big deal that we check the conditions. Right. We've been grading FRQs for a while now. One section of the FRQ, right? There'll be basically, when you create a confidence interval on a FRQ question, one question will be, did you state that you're creating a confidence interval? One point will be just checking conditions. Like that'll be one section. And E, a P, or an I will be just for the conditions. So if you check your conditions, you're going to get a 1 on the problem at a minimum. And if you check your conditions, if you don't check the conditions, you've already lost one of the 4 points available to you. All right, and so random. Was sample random? You'd have to check that. And you could simply say sample was random as stated in the problem. Normal, you're going to have to check that NP hat is greater than 10 and n times 1 minus p hat is greater than 10. You cannot merely state that. You actually have to plug in your values for n and p hat and calculate them and show that those numbers are bigger than 10. And then independent, you'd have to say your sample size, and you'd have to show that it's less than 10% of the overall population. Once again, you're going to have to either mention what the overall population is and mention your sample size and mathematically show just a simple calculation that it's less than 10%, or you have to basically say, well, it's reasonable to assume that there are more than blank number of people in the population. Because a lot of times you won't know the population, but if you, like, let's say you had a sample size of 300 high school seniors, and you were trying to make inference about the entire population of high school seniors in the United States. Well, then as long as n is greater than or equal to 3,000, then we're okay. So we would say it seems reasonable to assume that we would write a sentence. It seems reasonable to assume that there are more than 3,000 seniors in America. Now, when we estimate the standard deviation from the data, we call it a standard error. So instead of, it's the standard error instead of the S of whatever. So, and that's just a small nomenclature issue, but because we don't have the standard deviation, we're estimating with standard error. Because we do not know what P, we're estimating it. You know, the formula for sigma P hat is P times 1 minus P, my smartboard's a little bit off, I apologize. 1 minus P over N is the square root. But we don't have P, so we would do the standard error is the square root of P hat times 1 minus P hat over the square root of N. It's the exact same thing they said. I still have to describe to you how to define the critical value, but the standard deviation statistic is just that standard deviation you were finding on that last unit test. What is the standard deviation of the sampling distribution? And we don't have exact values for P, so we will estimate it with the standard error. All right. So how do you find the critical value? If the normal condition is met, we can use the normal curve. To find a level C confidence interval, we need to catch the central area C under the standard normal curve. And we're going to call that value, the critical value, we're going to use Z values, we're going to call the critical values Z star. Let's say that as Z star. And you're going to use table A or your calculator, and we're going to use the table. And you can check this. If you take out your textbook and you turn to the textbook, you'll actually, in the back of your book, and you look at the bottom of table B. So in the textbook, it's table A on the AP exam, but it's table B in your textbook. And you look at the bottom, and you'll see Z stars listed, and then they actually even have the confidence levels. Let's see if I have a picture of that. No, I do not. Hold on one sec. So you would go to your confidence level, and you'd go to the bottom of table B. And this is, in your book, it's labeled Z star. And on the AP exam, it's labeled in infinite degrees of freedom. This is off the T distribution. We're going to learn what a T distribution is, not the class after next. And we'll learn what that is, but we don't need it. So you would go to this last line here. So a 95% confidence interval, your critical value is 1.96. A 99% confidence interval, your critical value is 2.56. And this is based on how many standard deviations from the mean contain 99% of the area, contain 95% of the area. Right in here, 68% would be a number real close to 1, because that's within 1 standard deviation of the mean. And so you can just go and get your critical values there. And this is just showing that same idea. Is to find a 95% confidence interval, we use the critical value of negative 1.96, because when we do this 68, 95, 99.7, we're rounding a little bit. And so the critical value for 95 is actually not 2, but 1.96. And if we do that, then we have 95% of the area. And so that's how you find your Z star. And we're going to be doing, basically all in class we're going to do is be creating confidence intervals for p hat. We'll have to check, so you would state what kind of interval you're doing, you would check the conditions, you would do all the math, and then you would write a sentences at the end to complete it. And that's how you would do one of these problems. All right, that's it. We'll be getting right into this next class. That was kind of a longer video. Don't want to give you too much, so I will see you next class.